I was talking about with you. Does that make sense? Yeah. Looking at a graph of the derivative, all the chapter 2 rules and stuff you've been doing apply to the graph of the derivative to give you information about the original function's differentiability. Does that make sense? This is a graph of the derivative. It gives you the specific value. In order for this thing to be differentiable, every place on that graph, the limit from the left has to equal the limit from the right, has to equal the function value. Otherwise, that function's not continuous, which means this function is not differentiable at that point. Does that make sense, you guys? Now, what's going to be hard is just putting everything in its category. See how, Eleanor, that's already getting kind of like, where am I? You're getting lost in the shuffle. Am I looking at the graph? Am I looking at the derivative? What am I even looking at right now? You know what I'm saying? Well, that's good. I'm just saying in general it gets a little muffled. Okay? But there's all these, the chapter 2 is just talking about, continuity. In chapter 3, before we get into the rules, which is the next section, we're looking at like, where is this thing even differentiable at? Okay? Any questions on this problem? Well, I want you guys to do something for me. Can you guys do something for me? Everyone look at number 24 in your books. Chris, you're going to have to share that up. What I want you to do, it's 24 through 28. Problems, you got a book? Here, use this. In problems 24 through 28, you're given a function. Here's what I want you to do, Rafi. I want you to use your detective work. Yes, your detective work. Put your hat on. I want you to graph this function on y1. And then on y2, keep your derivative of y1. And I want you to take a look at a picture of just the derivative. And from that picture, I want you to see if you can tell me what the function is. Does that make sense, Nathaniel? So what I want you to do is take the derivative of that function without taking the derivative of it. By taking a picture of it, by looking at a picture of it, and taking a guess at what it is. Marco, does that make sense what we're doing right now? Alright, get on it and we're going to look at some of these. Picture of the derivative of y1. There. Any guesses? So does that make sense what we're doing, guys? We're actually taking the derivative without actually going through the whole definition of the derivative. You know what I'm saying? Because if you had to multiply out this x to the 4, it would take some time to do it algebraically. You know what I'm saying? But any guesses what this function is? Tangent? X cubed. Well, what about, is it half x cubed? Is it like 2x cubed? I don't know. What do you guys think it is? How do you know it's x cubed? What can we do now? Take a look at your table. We have our guesses. We have our hypotheses. Make sure your table's set up, you guys. Let's start at 0 and count by ones. And let's just take a look. Do these numbers fit the x cubed function? Yes? Lauren? So what have you just done? Wait a minute, what have you just done? What have you just done? What? You can say it, tell the whole class what you've just done. It's too late now. You have to tell them. To what? I don't understand what that means. Roxana, what's he talking about?
We found the derivative of that value.
Of that function.
Of it.
You're looking at specific points, Wayman, to verify. You've bypassed the entire definition of the derivative. Huge algebraic process. And again, what the picture tells you, it doesn't give you the actual equation. You know what I'm saying, Jessica? But it will make a picture for you and give you points. From the points, we actually figured out what the equation was for the derivative. The derivative of 0.25 x to the 4 is did it using we put our hat on, Rafi, and we did our detective work. Try the next one. What's the next one? Negative cos x? Is that the next one?
Yes.
Try it. You guys, everyone do a zoom trig. You guys know what zoom trig does? It changes your viewing window to count by from negative 2 pi to 2 pi, by pi over 2s. So instead of zoom 6 or zoom standard, hit zoom and then go down to trig. And I want you to take some guesses on what the derivative of negative cosine of x is. Well, we'll talk about it. Since we think we're all fancy now with all of our work with the trig and everything, and we're like taking derivatives and stuff. Any guesses? The sign, did you verify it on the table? Don't be just throwing potato sandwich out at me. I don't know. I don't like potatoes on a sandwich. It's like double starch. You know what I'm saying? That'd be weird. You know what I'm saying? Look at your table. Go through your reference triangles. At 0, what should the sign be? At pi over 2, what should the sign be? What are you looking at your table? How can you change your table to make it what you want, to match your graph? Did anyone move around their table a little bit? All right, let's take a look at this one. Okay, negative, everyone should be in radians because we're never reading the rest of the year.